All right, this problem gave us a little bit of trouble in class the other day, but unpressured, it's a very reasonable question. So it says write the first four non-zero terms of the Taylor series around x equals 0. Well, we know that we're going to have to take four derivatives because f of 0 is 0. So if we need four non-zero terms, we're going to have to get four derivatives. So let's start deriving. F prime is 3 times 1 plus 3x to the negative 1. F double prime is negative 3 times 3 times 1 plus 3x to the negative 2. And one of the things that's really helpful when you do these problems is to not be simplifying these numbers. Don't write that negative 9. It's helpful to carry out the numbers so that we start recognizing where and how numbers arrive so that we can see the pattern easier. So now we get 2 times 3 times 3 times 3, 1 plus 3x to the negative 3. And our fourth term, negative 2 times 3 times 3 times 3 times 3 times 3, 1 plus 3x to the negative 3, or sorry, to the negative 4. And even though I don't need to go to the fifth derivative, I'm going to just for one more data point. So when this 4 comes down, we get 2 times 3 times 4 times 3 times 3 times 3 times 3 times 3. Okay. Notice here 4 factorial, 3 factorial, 2 factorial, 3 to the 3, 3 to the 4, 3 to the 5. Okay, so these are the derivatives, but we want to find these derivatives at 0. So at x equals 0, we end up with just 3 and negative 3 times 3 and 2 times 3 times 3 times 3 and negative 2 times 3 times 3 times 3 times 3 times 3 and 2 times 3 times 4 times. And when you write it like this, it's clear to see that we have, you know, the number of threes is going up by 1 each time, and the factorial is going up. So as we write this in a Taylor series, we're going to get t equals, well, 3x plus, or rather minus 3 times 3x squared over 2 factorial plus 2 times 3 times 3 times 3 x cubed over 3 factorial minus, well, yeah, minus 2 times 3 times 3 to the 4th over 4 factorial x to the 4th. And I'm going to write one more. So that's right for A, but I'm going to write just one more term for my own sake. So then plus 2 times 3 times 4 times 3 to the 5th x to the 5th over 5 factorial. And when writing it like this, now all of a sudden we're like, okay, I see the pattern. So we have t equals 3x minus 3 squared x squared over 2 factorial plus, well, so plus 2 factorial 3 cubed x cubed over 3 factorial minus 3 factorial 3 to the fourth x to the fourth over 4 factorial plus 4 factorial 3 to the fifth x to the fifth over 5 factorial. And so therefore, now we see it. We know what that the general term is going to be. The general term t will equal from, and I'm starting at n equals 1 to infinity. We have 3 to the n x to the n over n, and then negative 1 to the n plus 1. And you may be thinking, like, where's this n? Because we have these factorials. So just as a reminder, or n minus 1 factorial over n factorial equals n minus 1 factorial over n minus 1 factorial times n, and you cross off and you just get n. So here's my, that's my Taylor approximation. So I just did both A and B. Now it says, for what values of x will my function converge? So to answer this problem, you need to use the ratio test. So we're looking at the limit as n approaches infinity of the n plus 1 term over the nth term. So just to have our sum up here so that we see it, we've got negative 1 to the n plus 1, 3 to the n, x to the n over n. So when we do the ratio test, we don't need to consider that portion. So we have 3 times 3 to the n times x to the n over n plus 1 times n over 3 to the n x to the n. Lots of things go away. And this needs to be less than 1 for it to converge. So 3x needs to be less than 1. So x needs to be less than a third. So those are the values for which my function converges. And for D, for part D, we just need to understand what it's asking. So the key thing is that we need to answer A. A needs to be a rational number. Okay, so because you could say, well, if this is true, then A must be less than 1/25 plus ln of 1.5, just solving this absolute inequality. But that's not a rational number. So what the theory behind this question, what they're trying to get you to see is to use the error that occurs from an alternating series. So we know that my function is alternating because of the -1. And what we know is that if we're using just a finite number of terms, like n terms, that the actual value, here's the actual value, minus our estimate, the absolute value of that is going to be less than our n plus 1th term. And that's when a series is alternating. So we need to remember a couple things. First thing, this series is ln of 1 plus 3x. That's the series that we were approximating. So we could rewrite this first statement as the absolute value. Now, order of subtraction inside of an absolute value doesn't matter because order and subtraction will just change the sign, but the absolute value makes everything positive. So I could write this as ln of 1 plus 1/2 minus a, and that needs to be less than my n plus 1th term, and in this case, we want it to be less than 1/25. So writing it like this makes it clear that a is the sum of my first n terms. And because our approximation gives us in fractions, gives us numbers in fractions, it's going to be a rational number. Okay, so what we need to do here is just through inspection figure out when does my n plus 1th term become less than 1/25. So I think a table might be nice. So when n equals 1, we're looking at the second term and just the absolute value of it. So that equals 3 squared times x. Oh yeah, so x, we need to find out the x value. So since it's ln of 1 plus 1/2, and we know that our original function is ln of 1 plus 3x, therefore 3x must equal 1/2, so x equals 1/6. So going back, our second term is 3 squared times 1/6 squared over 2, which equals 1/8. That's not less than 1/25, so this doesn't work. So we have to keep going. So when n equals 2, we're looking at our third term, which is 3 cubed times 1/6 cubed over 3, which is 1/24, not less than 1/25. So we need to keep going. N equals 3. So we look at our fourth term, 3 to the 4th, 1/6 to the 4th, over 4. And this equals 1/64. So this is less than 1/25. So when n equals, if we were to use 3, if we were to use a third degree approximation, let n equals 3, then our fourth term equals 1/64, which is less than 1/25. So what that's going to what that'll make true is that my error will be less than 1/25, which is what I'm looking for. So let's find. So therefore, ln of 1 plus 1/2 minus s of 3 equals, well, is less than 1/64, 1/64. So therefore, obviously less than 1/25. So now we need to find out this s of 3 value, s sub 3 value. So find this, because that's our a term. So to find s sub 3, we're just going to add, find the sum from n equals 1 to n equals 3 of -1 to the n plus 1 times 3 to the n, x to the n over n. And doing that, we 3 over 6, which is n equals 1 term, minus 1 over 8, which is my n equals 2 term, plus 1 over 24, which equals 5/12. So the question was to find a rational number, a, such that ln of 1 plus 1.5 minus that a value gets you to 1 over 25. And we did it.